Solve the following inequality. Write your solution in interval notation. Well, it's going to be a bit easier to determine where a function is greater than or less than 0 rather than some number like 18. So the first thing I'm going to do is bring everything to one side of the equation. The solution to this new equation, or inequality I should say, is going to be equivalent to what it was otherwise. Now, in order to get some work done with this, I'm going to need to factor this polynomial. Since it's a quadratic, that should be fairly straightforward. Let's see, two things that multiply to 2x squared would be x and 2x. Two things that multiply to 18 could be 2 and 9, so actually I'll put the 2 there and the 9 over here. The reason I'm doing that instead of putting the 2 here is because 2 and 2 would share a common factor, and that would only happen if there's a common factor of the entire polynomial. All right, let's see. So 2 times 2x would give me 4x. 9 times x would give me 9x. Well, that's not going to work. So let's try some other possible values here. I believe we could try 18 and 1. So let's put 18 here and 1 there. And this doesn't actually look like it's going to work because that's going to be 36, and that's way bigger than the 9 here. Let's see, 9 and 2, 1 and 18. I haven't tried 6 and 3. So let's try 6 and 3. Let's see what happens there. All right, 6 times 2x would be 12x. 3 times x would be 3x. If the 12 is negative and the 3 is positive, then that would add to negative 9x. There we go. All right, so I need this to be negative and that to be positive. Now, the zeros of this, I could set each factor to equal to 0 and solve. But positive 6, and then if I take 2x plus 3 and set that equal to 0, 2x equals negative 3, or x equals negative 3 halves. All right, now let's put these on a number line. Negative 3 halves go right here, and 6 right there. And what I want to know is, are the intervals between these numbers entirely positive or entirely negative? So I'm just going to pick a value in each interval. So how about negative 2, 0, and 7? And then I'm going to plug that into my quadratic here, and the factored form is usually easiest. So negative 2 minus 6 is negative 8. 2 times negative 2 is negative 4 plus 3, so that's negative 1. Negative times negative is a positive. And then 0, if I put that in, that would be negative 6 times positive 3, so that's a negative value. If I put in 7, it would be 1 times 14 plus 3, which is 17, so that's a positive value as well. All right, so now I'm looking for values that are less than or equal to 0, so I need them to be negative. So that's this interval right here. But the question is, do I include the endpoints? And because it's less than or equal to, I will include those endpoints. So the final answer here in interval notation is the interval from negative 3 halves inclusive to positive 6 inclusive.